In this video, we're going to define what the hyperbolic functions are and prove the identities. So the first hyperbolic function that we're going to introduce is one called Hyperbolic Sine of X, pronounced Sine of X. And that's going to be equal to, it's defined to be equal to a half e to the x minus e to the minus x. And the hyperbolic cosine, or cosh x, is defined to be a half e to the x plus e to the minus x. Now it can be difficult to remember which of these correspond to which, but the way I remember it, sine x has the subtract, so s for subtract. Now the reason that these are called hyperbolic trig identities is because they behave very similarly, with a few exceptions, to trigonometric functions. So the identities for trig functions bear some resemblance to the hyperbolic functions. So let's put this to the test by writing down all the trig functions that we can. So trig identities. And we'll stick to the ones that you need for the syllabus. So you've got sine squared x plus cos squared x is identical to 1. You've got cos of 2x is identical to cos squared x minus sine squared x. Another version of that is cos of 2x is identical to 1 minus 2 sine squared x. And a third one, cos 2x, is identical to 2 cos squared x minus 1. Now all of these you need to know for single maths. And finally, sine of 2x is identical to cos x sine x. So they're all the trig identities. And we're going to write alongside them the hyperbolic counterparts. So hyperbolic identities. So here we've got cosh squared x minus sine squared x is identical to 1. Cosh of 2x is identical to cosh squared x plus sine squared x. We've also got cosh of 2x is identical to 1 plus 2 sine squared x. We've also got cosh of 2x is identical to 2 cosh squared x minus 1. Then finally, sine of 2x is identical to 2 cosh x sine x. And notice the striking similarities, and also one main difference. So the way I think the easy way to remember the hyperbolic identities, and this works in most cases, is that the hyperbolic identities are identical to the trig identities, apart from whenever we've got a sine squared or a sine squared, the sign changes. So here, the sine squared x was positive. Here, the sine squared x is negative. Here, the sine squared x is negative. The sine squared x is positive. Sine squared x negative. Sine squared x positive, etc. So if you know your trig identities, then this is a really quick and easy way of remembering the hyperbolic identities also. So now we've got all the identities written down, let's have a go at an example question of how these can be used. So this question says, using the definition of cosh x in terms of e to the x and e to the minus x, prove that cosh of 2x equals 2 cosh squared x, take 1. Let's get straight in there and do this one. So, cosh of 2x, from the exponential definitions, is a 1/2 e to the 2x plus e to the minus 2x. Cosh of 2x, from the exponential definitions, is a 1/2 e to the 2x plus e to the minus 2x. Cosh of 2x from the exponential definitions is a 1/2 e to the 2x plus e to the minus 2x. So now looking at the right hand side, 2 cos squared x minus 1, well, we know that cos x is defined as being half e to the x plus e to the minus x. Now let's sub that into the right hand side and show that it's equal to the left hand side. So 2 cos squared x take 1 is equal to 2 times a half e to the x plus e to the minus x squared take 1, which is equal to 2 times, and let's square the half first, so 2 times a quarter, and then do the double brackets, e to the x plus e to the minus x, e to the x plus e to the minus x, take 1, equals, well, 2 times a quarter is a half. Expanding the brackets now, we get e to the 2x from that. E to the x times e to the minus x is e to the 0, plus 1. Then this one here, plus another 1. Then this one here, plus e to the minus 2x. Take 1. And now just tidying this up, we get equals a half of e to the 2x plus 2 plus e to the minus 2x. Take 1 equals, I'm multiplying out just this term here, the 2. We get a half e to the 2x plus e to the minus 2x plus, and a half times 2 is 1. Take 1 equals a half e to the 2x plus e to the minus 2x, which, as we saw previously, just a bit higher, sorry, this one here, as we saw previously, was cosh of 2x. And that's the proof done. So let's now have a look at part 2 of the question. So it says, hence solve this equation here, cosh 2x minus 7 cosh x equals 3, given your answer in logarithmic form. So copying that equation down here, there it is there, I'll pop that there. Cosh of 2x minus 7 cosh x equals 3. Okay, so cosh of 2x, we learnt, was equal to 2 cosh squared x minus 1. Okay, take 7 cosh x equals 3. And we can see we've got a hidden quadratic there, a stealth quadratic. So taking everything over the left hand side, we get 2 cosh squared x minus 7 cosh x, take 4 equals 0. Then let's try and factorise that. So 2 cosh x, there, go in the brackets there, equals 0. Okay, so we want to get minus 7. So we do minus 4. That gives us minus 8 cosh x, and plus 1 brings us back down to minus 7 cosh x. Okay, so now we have 2 cosh x equals minus 1, and cosh x equals 4. So that's cosh x equals minus 1/2. So now solving these, we get that x equals the r cosh of minus 1/2. And it asks for the answer in exponential form. So what we're going to do now is have a look at the formula booklet, because in the formula booklet it gives us, in terms of logarithms, the inverse hyperbolic trig functions. So r cosh of minus 1/2, well, r cosh, we can see the inverse cosh is there. So now subbing minus 1/2 into there. However, notice that r cosh is only defined when x is greater than or equal to 1. So this actually is an invalid answer. So we'll cross it out and just write, since x must be greater than or equal to 1. So when we discard answers, we should always say why we're discarding answers. Right, so the next one, cosh x equals 4. So x equals r cosh, the inverse cosh of 4, which is equal to, sub that in, log of 4 plus the square root of 4 squared minus 1, which is equal to log of 4 plus root 15. And that's the question done. That's what it asked us to do. We've given the answer, we've given the solution in logarithmic form. For more videos like this, subscribe to our YouTube channel, and to find out more about our Skype tuition and revision courses, go to alevelmathsrevision.com.